morningers. Today our lesson is chapter 4, lesson 6, triangle congruence by ASA, angle, side, and HL. Now, yesterday we've studied this case, which is angle, side, angle, in example 2. And now today we're going to have to study example 3. Example 2, to remind you, it said that if we have two sides congruent and two angles, like this angle is congruent to this angle, for example 30 and 30, and this one, for example 70, and this is 70, so the triangles are congruent by angle, side, angle, because I have two angles and one side, two angles and one side. And we said that you should note that the side should be adjacent or next to the two angles, like this. If you can see, they are all next to each other, the side and the two angles. Now, the good news is that today we're going to have to study example 3. And example 3 says that, okay, you can prove two triangles congruent by angle, side, angle, or by having two angles on one side, but it is not necessary for the two angles to be next to the side. These two angles are not necessary to be next to the side, okay? It can be, for example, this angle and this angle. So any two angles and one side will be enough, okay? Let's see how is this going to be. For example, if you have this figure in example 3, and they said that we have to prove that triangle ABC, this triangle, and EDC, this one, congruent. Now, first I can clearly see that BC is equal to CD because it's given. So BC equal to CD because it's given. Now, always when I have this like an X, I always think about vertical opposite angles. So the angle C in this triangle, angle ACB, is congruent to the angle C here, which is DCE, because vertically opposite angles. Now, we still need a third feature. You can see that these two lines are parallel. Directly, whenever you have two lines parallel, you should always think about internal alternate angles, interior alternate angles, and exterior alternate angles corresponding, and so on. So if you see that since these two lines parallel, so I have the alternate interior angles congruent. For example, if you look at this, if you can see, angle D here will be equal to congruent to angle B here, because these two lines are parallel. So angle ABC is congruent to angle CDE because alternate interior angles. Are equal, they are equal. So now I have one angle, two angle, and one side. Without looking to that, where are the two angles, where are they situated? Are they next to the side or not? That's it. If I have two angles on one side, so I say they are congruent. The triangles are automatically congruent. So triangle ABC and triangle CDE are congruent by what? By angle, side, okay? Two angles and one side. No need for the side to be included in between the angles. Now, we do now check it out 3. Note that after we finish check it out 3, I'm going to ask you a kind of challenging question. Okay, so stay with me. Check it out 3. Also, we have to prove that the two triangles, the one that here and the one here, that they are congruent. So you can clearly see that this equal to this. So JK is equal to JM given. And you can clearly see that K equal M. The angle K is congruent to angle M. So angle K is congruent to angle M, because it's also given. So this one is given and this one is given. Now we still need, I have an angle on this side, so I still need another angle. Now they mentioned in the given that this one, JL, is a bisector of this angle. Now if you remember, if you have a line bisector, the bisector cuts an angle into two equal halves. So this will be as if it's like, if this is 40 degrees, so this is 40 degrees. They will be equal. So automatically this angle will be equal to this angle. So angle KLJ is congruent to angle JLM. Why? Because JL is a bisector of angle KLM. So now I have these two angles congruent. So I have one angle, two angle, and one side. So the triangles JKL and triangle JLM are congruent by angle side, any two angles, and one side would be enough. Okay, now I've told you that I will ask you a little bit challenging question. The question is that if I said yesterday that the side should be included between the two angles, and today I'm saying that it can be any two angles and one side, angle side, which means that it's not necessary for the side to be between the two angles. How come? This is the question. How come that it can be any two angles and not the ones that are next to the side? Think about it, because yesterday this was a necessary condition. Why today it's not a necessary condition? Why? There is something I can do. I want you to think about it. So if you found out the answer, send it to me, okay?